In this video we're going to make a Pear Cam, and we're going to use parameters to define the critical dimensions for the Pear Cam, and that will allow us to change the overall size of the Pear Cam very easily, as we might want to do if our box that we're going to house the Pear Cam in changes. So we're going to do what's called parametric modeling, and what it does is it allows us to make an object whose size, but not the shape nor the relative dimensions among the features on the part, can be changed easily. So again, the overall size can be changed easily. We'll find that the dimensions that we set in Inventor are given names in the following order: D0, D1, D2, D3, and we'll use that. And we'll use the parameters window to monitor all the dimensions as we make the part. So let's take a look at the part we're going to make. Here it is. Here's the Pear Cam, and it tells us that we have a nominal diameter called D that we're going to define, and then all the subsequent parameters, or I should say all the subsequent dimensions, are parameterized as shown here, D0 through D5, and they're defined in terms of this value D. So let's start that. So the first thing we're going to do is we're going to define this nominal diameter D. So let's go to Inventor, and up here we've got the shortcut to the parameters window, and we're going to make a user parameter. So add numeric. I'm going to call it D. I could call it nominal diameter, one word. No spaces are allowed in there, but we'll just call it D. Right now we're going to keep it at 1 inch, and for the comment here, I'm going to put in nominal diameter. Done. Now everything I do in terms of dimensions I can make in terms of that value D. So let's go back and look at what we're going to do. So the first D we have here, first dimension is D0, and it refers to the size of this large circle here, and they call it the radius of maximum diameter. And you got to be careful. This is not a diameter; it's a radius, and it's equal to what is that equal to? We're going to come down here and we're going to decide what they're equal to based on what we're shown in this column here. So if I come here and I put them in here, so the radius is 1/2 the nominal diameter, so I can say something like 1/2 times D. And the minimum radius, which is the one up here, D1, that is going to be 1/4. And again, this information is just made up by the creators of this assignment, and we can define these however we like. The key thing is we're defining everything in terms of D. And the offset, which is D2, the distance between the centers of those circles, is going to be what value? 1/2. And I can also put 0.5 times D. For no reason at all, I'm going to put 1/2 times D. And now I think I'm ready to go. So for again, this is a radius. Let's bold those because it's very confusing. Usually we work in terms of diameter. So let's make that bottom radius 1/2 D. And the bottom radius I'm referring to is the radius associated with this circle on the bottom. So let's do that. We're going to put a lot of work planes and axes on these cams to get them to work well in an assembly. So we want to decide where our center is going to be wisely, and I want the center to be the origin to be right here. And you can see that I've already got it set up for radius. Usually it's not like this. I have diameter when I pull out like this on a circle. If I right click and change to diameter, you can see now I've got the diameter. That's what the default is and what we usually use. I'm going to right click and change this to radius, and here, since I know that the dimension associated with that particular feature is 1/2 times D, and it is the radius, I can just put in 1/2 times D here. So I'm just going to put D/2. And you can see it's got the little fx, which means a function, and it's 1/2. Why is it 1/2? Well, we can always go back to our parameter table and see that if we define D0, that first dimension we made, which is the radius of that circle, it's 1/2 D, and we've defined D as a user parameter here as 1 inch. Okay, what's the next thing we need to take a look at? Well, D1 is equal to the minimum radius, so the radius of the smaller circle up here. And we're told down here that that's 1/4 d. So let's make that. I'm just going to make it right here and d over 4 in terms of radius. And I'm going to use the geometric constraint of vertical to make sure those centers are right on top of each other. So far, so good. Now I'm going to go to the next parameter. So we've used D0 and D1. So D2 is the next one, and it is called the minimum offset between the two circles. And that value of D2 is equal to 1/2 d. So I'm going to come here, over to here, here, and bring it out here. This is d over 2, 1/2 d. Okay. Now we don't really have anything to worry about until we get the profile of the PairCam finished. One way to do that is to take the lines, and you can just make 2 lines out here and use the wonderful features of these geometric constraints to get them to be tangent to what we want them to be tangent to. There we go, and then finally here we can go here, right click OK. Now we want to trim away the stuff we don't want. And finally we end up with the pear-shaped two-dimensional figure. Let's continue and see what we need to make next. So it would be D3, and that's going to be the radius, or is it the radius or is it the diameter of the hole here? But it's the diameter, so you got to be careful here. So we're going to have D3 is a diameter. That's what the axis goes on. That's sometimes a square. Right here it's a circle. So for the whole diameter, we don't have any formula. We've fixed it to 3/16. Say we've got a stick that we're using as the axis, and that's going to stay 3/16. So we can put that right there. And when I make it, however, I need to be careful. And you can see it's a radius here, so I'm going to right click, go to diameter, and then put 3 divided by 16. And there it is, right click OK. And I think we have everything necessary before we can extrude now. Let's check the table here. And I think we have everything all the way up to D3, which is right here, whole diameter. When we do our extrusion, we're going to get 2 parameters. Of course, we're going to get the thickness. And we see that that's also 3/16. That's a given. We may increase that later, but for right now, it's just a fixture number. It doesn't change. And then when we extrude, typically that extrusion is at a 0-degree angle, and that's going to be the case here. So no more formulas, and we can just go ahead and finish the sketch. We're going to extrude in this region. Choose the symmetric extrusion because we want the axis of the coordinate system to be in the middle there. This is also 3/16. And then there is our PairCam. I'm going to save this. We're going to call this, at least the latest assignment, PairCam 2. We've already made one PairCam. And I think I've already made a PairCam 2 before. So I'm going to call this 2A, but I believe in the assignment it's 2. So there it is. Let's check out the eye properties. Update 0.166. I believe that's correct. But now there are even more things that we can include in our image that we turn in. So right click, eye properties, physical, update. We got 0.166. And actually, in fact, I think we're asked to change this to ABS plastic, so we can come over here and change it to ABS plastic, and we can make it some color like, let's see, smooth yellow. And so let's right click, eye properties. Let's get the physical tab, so we got the volume. Now let's go up to, oh, it won't let us. How unfortunate. So let's come here. And so this is what I want you to display when you turn this in. Now it looks like it's going to be kind of hard to display everything. So I'll talk about in class how I want you to display both of these. One method would be to use the snipper tool. And we can come over here. We can grab all this. Let's try that again. Missed it again. Let's try down here like that. And then we can somehow add the volume in there, but I'll figure out a way to do that. That's quite an annoying sound. Okay, so that's what we have. So your parameters table should look like this. Now, why would we ever want to do this? Well, what if I change this to 2? So I have a really big box I want to put this cam in, so I say done. Now there's this little tool up here we haven't used much called the local update, so I'm going to press it, and you can see that it gets bigger. So if I go back to the parameters and say this is 1 inch, done, and then I update it, we'll do that. Now for our little boxes, we might want to come here and make this 0.75. Will that still work? Let's see how that does. Done. Yeah, I think it'll probably work. Thanks for watching.